let's finish out this lesson. Hopefully grab a snack, some water, and you're ready to go for the final 3. So, example 5, graph f of x equals negative x cubed plus x squared plus 3x minus 3. So, starting fresh blank might seem overwhelming, but let's just take it step by step with what we've learned today. Today we learned end behavior, so we'll know where our graphs are going to end up, so that's going to be important with picking coordinates of our point. Yes, we have graphing calculators, I know that, but what if it's a little bit easier than that? We can just plug points in and graph it that way as well. So, if I'm looking at my function, I have x cubed plus x squared plus 3x. My highest degree is a 3. So that's going to be an odd number, and then I have a negative leading coefficient, so that I know my end behaviors are going to be going this way and this way. Okay, so as x goes to negative infinity, y is going to positive infinity. As x going to infinity, y is going to negative. So I can look at my table. If I was to create a little table, let's say this is going to be my x values, and this is obviously when I say my y value, that means I'm taking my function of x that I pick. Like, let's say let's pick smaller numbers because I know this is going to be stretched out. So negative 2, let's go negative 1, 0, 1, and 2. Okay, we know my y-intercept is going to be negative 3 based off this constant. So that's a good point to recognize that it is passing my y-axis. And so why am I picking these points? Well, because I know it's going to be crossing the 0 at some point, and I know it's going to be at negative 3. And so I can pick to the left of my y-axis and to the right of my y-axis. If I didn't have a constant, I know that it might not hit my y until possibly later or not at all. And so then I can pick which quadrant I want to go from and which coordinates where. So with my end behavior picked, I know I'm going to be an arrow over here and an arrow down here. So picking those coordinates is going to help me. So y equals negative x cubed plus x squared plus 3x minus 3. You want to take a second and plug in these coordinates to graph them. Go ahead. But I'm just going to list them out because, again, I can't show my calculator. But where am I getting them? I'm taking this negative 2 and I'm plugging it into this function. Okay, so negative 2 cubed plus negative 2 squared plus 3 times negative 2 minus 3 is going to get me a 3. Negative 1 cubed, double negative, plus negative 1 squared plus 3 times negative 1 minus 3 is going to get me a negative 4. And then we know if I plug in 1 to all of these, I'm going to get a 0, because hopefully we graphed that in our calculators already. And then plugging in a 2, I'm getting a negative 1. So I'm going to plot my points. So I have negative 2, 3. I have negative 1, negative 4. And I have 1, 0. And then finally 2, negative 1. And if I was to just have these points, it'd be kind of confusing. But because I know my end behavior, I know my graph is going to start with an arrow up here. So I'm going to have an arrow. I know the coordinate hits through here. It's going to go down. It has to go back up to touch these points. And then where would I go here? I'm not going to shoot back up, right? Because I know my end behavior is going towards negative infinity. So what I'm going to do is have my arrow. I continue on connecting my points. And then I know my arrow is going downwards because of my end behavior. And that is a rough sketch going by hand for a polynomial. Okay? Now, let's go through example 6, something that might be asked of you on ACT, SAT. Example 6, sketch a graph of a polynomial function f with the following characteristics. Well, they're telling us are decreasing, which we learned last section, or the one before. So decreasing only on negative infinity to negative 2 and 3 to infinity. We have f as greater than 0 only on negative infinity to negative 4. Okay, so if we have x to negative 2, that means it's decreasing. So at the point of negative 2, I'm going to be a decreasing function. Because remember, you're going down from left. Like if you're reading your function, you're reading it from left to right. So if this is me, I'm going to put my little person. I'm riding my roller coaster. I'm going wee all the way down my roller coaster on my function to negative 2. But I'm also decreasing on my function that was at 3 this way. Okay? And so with that being said, I know my end behavior of this function is going to look like this. I'm going to have end behavior here and here. And if it's saying that f is going to be greater than 0 only on -3 and -4, and then 0 to 5, I know I'm not going to be at my values of, on my x-axis, I'm going to be below because f is going to be greater than 0. That's why. So if I have my values of -2, let's say, let's stretch it out. This is going to be 0. Let's call this, we'll call this 1, and then this will be my value of 2. So this is 1, this is 2. Now I have my coordinate point here, okay? I know I'm going to be going up, and then from -infinity to -4, it's going to be less than or greater than 0. So I know I'm fine there because I'm at the value of -2. And I'm going down. Oh, what's going on with my graphing? My tool. Going down, but I know I'm going to hit my origin, right? Because it says f is greater than only on -3 and -4 and 0 to 5. And so from 0 to 5, I'm going to have to go above, and then I'm coming back to decrease when I'm at 3, and we'll call this 3. So I'm going to hit somewhere up here. Go, oh my goodness, what is it? My pen, it's going haywire. Going down, crossing my origin. I'm going to go up, but then I'm going to decrease back at 3. Just like so. And that's a rough estimate of sketching a graph. Okay, again, step by step. So they give us this information, they give us this information, so we know that we're okay. Okay, moving on to the final one. It's our word problem. Example 7. And I know I did typo, so change out 6 to 7. The estimated population in thousands or a city can be modeled by the polynomial function of p of t equals 0.613 t cubed minus 18.40 t squared plus 154.5 t plus 341, where t represents the number of years after 2000. Using technology to graph the function for 0 between where t is going to be greater than 0 and t is going to be less than 18, describe the behavior of the graph. So take a second. You can use Desmos on your computer or phone, or you can use your graphing calculator. But if you plug this function in, you're going to notice that, again, because I can't show my calculator, I can't show it, but you should have it graphed, and then you should see that the population increases, because we're starting from the year 2000, and then roughly to about 2006, because that's going to be 6 years later, but then it decreases until about 4 years, or not 4 years, from 2000 to 2014, that it decreases, or from, 2006 to 2014, and then increases from 2014, 4 years later, to 2018. And again, that's just from looking at my graph. You can use Desmos or your graphing calculator, whichever you feel necessary. Okay, then it asks for letter B, what is the average rate of change in the population to 2001-2018? If we're in class, I would say, does anyone remember what average rate of change is another word for? And hopefully you're saying, it's slope, and it is slope, okay? So average rate of change is slope. And if we remember our slope formula, y2 minus y1 over x2 minus x1. And you're asking, well, how are we going to find our y values? Well, it's easy, because we're saying it's the year from 2001 to 2018. That is our y value. That's going to be describing our y value. And then if we're talking about just plain old years, we're just doing our 18 to the first year, because that's 2001, and then we're going to plug in our years to find population, because our y-axis is population, and then x-axis is time. So that means when the population is at year 18, I'm going to subtract it from the population at the first year, 2001, and then my x values are 18 minus 1 because it's year 18 and year 1. So using your calculator, because I have not much time, you're going to take your function right here that you have, p of t. You're going to plug in 18 into each value of t to find the y value, and you're going to subtract it from if I took 1 and plugged it in as well. I'm going to pause, type in your calculator, pause the screen, okay? When you plug 18 in, you should get roughly 735 and some change. We could just round to the 100th place. And then we're going to subtract. If I plug 1 in, I should get 477 and some change. Okay? And then 18 minus 1 is 17. So using my graphing calculator, using the fraction button. If you don't use the fraction button, don't forget to put these. Oh no, I erased a number. That was 7. And this. If I use just the division button, remember to put these in parentheses first and then divide off the 17. And you should approximately get 15. And this is talking about 15,000 people per year, because this is the rate of change. Based off of figuring out our 15,000 per year, it's asking, do we think this model can be used for years after 2018? Well, no, because if we look at our technology from A, we utilized it. If we look back at the function, it's increasing exponentially at 2018. So if we were, it can't, our population isn't going to increase infinitely at the time to infinity. So no, the population can't increase infinitely, shown by the model. Okay. All right, and that's it. That's 4.1. That's all we are doing. Make sure you go back, rewatch. You're going to be doing your 4.1 assignment. It's a handout, okay? It's a handout that you're going to be completing in class, and then we're going to check it when I get back on Monday. So I hope you had a great time doing this lesson. If you have any questions, feel free to reach out. And then, you know what, if you put a little smiley face on your homework when you turn it in, when I get back on Monday, I'll give you 5 points on our next assignment if you've watched all this. Awesome. So thanks, guys. Have a great time, and I'll see you on Monday. Bye.